Yeah. Oh, welcome everyone to today's lesson. This is Matt's Cruise. Um, this is Tambari, of course. And of course, I've been dropping my videos on regular basis. You can check my channel and see the ones I have actually uploaded. It could be very useful, and the videos are uploaded deliberately and intentionally. They're not just uploaded randomly. It is actually based on popular demand. Now, today we want to be looking at finding the LCM of whole numbers, but using prime factorization method. Now, we've done LCM of whole numbers before, but then we used multiple method. You can check that in the link, the description below. But this time around, we want to use prime factorization method. Please bear with me. Now, in case you also don't know how to use prime factorization method, I have a video on prime factorization, how to express number as a product of their prime factor. So that will really help you. So you need to watch those two videos. It will help you to understand this thing clear. So I don't make this video too long than necessary. So let's get right into today's duty. Today we're expected to use prime. So like if you're finding the LCM of 8 and let's say 8 and 12, you notice that 8 will be expressed as 2 times 2 times 2, and that is 2 raised to power 3. Okay, then that of 12 will be 2 times 2 times 3. In index form, that will be 2 raised to power 2 times 3. The idea about LCM is that when you are using prime factorization method to find the LCM of two whole numbers, you must ensure that you represent every factor, every prime factor that actually partook in the expansion. For instance, in this expansion, we see that we have only two unique sets of numbers, and that is 2 and 3. So you only go for the one with the highest power, the one with the highest power. For 8, we only have 2, so we are going for 2. Our LCM will be 2 raised to power 3 times. Now the second expansion for 12, we have 2 raised to power 2 times 3. We're not going to take 2 raised to power 2 because we've taken 2 raised to power 3 to represent the 2's family. Now for the 3 family, we'll go with 3 raised to power 1, which is this one here. So if you evaluate this thing, this is actually 8 times 3. 8 times 3 and 8 times 3 is 24. You know, I always encourage students to learn prime factorization method because it's not limited at all, but multiple method is limited. But this prime factorization method is not limited. Let's check how to find the LCM of let's go with 12 now. Did we just do 12? Yeah. Let's do with let's just deal with let's do with 16 now. 16 will be 2 times 2 times 2 times 2. I'm expressing it as a product of it prime factor, then I express it in index form. Also done a video on indices. It becomes 2 raised to power 4. Then I'm going to be dealing with 32. See, 32 will be, of course, 2 times 2 times 2 times 2 times 2. That's 32. Then in index form, 32 will be 2 raised to power 5. You see, now our LCM, we will consider the unique factors that are involved. We only have 2 to be the prime number all over, both in 16 and 32. So we're going to take the 2 that has the highest power, and that is 2 raised to power 5. And 2 raised to power 5, that means the LCM is 32, meaning the smallest number that 16 and 32 can divide with that remainder is 32. Well, that's the much we can take. Just use that pattern in resolving other ones so that we don't make the video too long than necessary. In case you have any question, you can hit the comment box and I will be glad to respond to you. If you've not liked the channel, please help me like the channel, subscribe to the channel, and hit the notification bell to get notified when I post new video. Thank you for your attention. Don't forget, you ensure that you represent all the factors. Then the factors represented must be the one with the highest power. All right, thank you.